So we've got two big products, or three massive products starting production next year. We've got Optimus, we've got Tesla Semi, and we've got the Cybercab.
The Tesla Semi is one of the three major products coming in 2026 that Elon Musk emphasized during the Tesla Shareholder Meeting event. Although it's a highly regarded vehicle, Elon Musk has rarely talked about the semi-truck lately, and there are three reasons for that. First, it's still in the testing phase. Its current specs, performance, and design are all prototype level, mainly for data collection. Second, Tesla still doesn't have a fully automated production line or a dedicated factory for the Semi. The total number of semi-trucks produced since 2017 is only around 300 units. Finally, the Tesla Semi still hasn't achieved what Elon Musk ultimately wants, a feature that could transform the entire trucking industry if successfully integrated: full self-driving. Yes, the big thing the Semi has been missing is full self-driving. However, Tesla has now solved all three of these issues for the newest version of the Semi. This will be the official production version rather than the current test prototype. It will be built entirely at the company's newly completed factory, making Musk's target of 50,000 trucks per year realistically achievable. Elon Musk has also revealed several major changes the Tesla team has made to the Gen 2 Semi to enable successful FSD integration. So what's new in this version? And how will the Tesla Semi convince truck drivers to make the switch? Let's get started.
We already have a lot of prototype Tesla Semis in operation. PepsiCo and other companies have been using the Tesla Semi for quite some time. But we will start volume production at our Northern Nevada factory in 2026.
This is Tesla's brand new factory built specifically for producing the electric semi-truck. As you can see, it could easily be considered a semi-gigafactory because of its massive scale. Previously, Tesla built the Semi almost entirely by hand, but with the new factory, production will shift to a fully automated assembly line. It's impressive that Tesla managed to put up such a huge facility in less than 2 years. And now we're getting our first look inside this new plant. With the new factory and automated production lines in place, Tesla says an annual capacity of 50,000 semi-trucks is completely achievable, giving them the ability to compete with the output of a traditional heavy-duty truck manufacturer. In the trucking sector specifically, Tesla's biggest competitor in the US is Peterbilt. They produce around 60,000 heavy-duty trucks every year at their Texas factory, and the company's total truck sales in the US and Canada reach roughly 300,000 units annually, a massive number that currently leaves Tesla far behind. Elon Musk is confident this new factory is a very solid first step toward making Tesla a formidable player in the heavy-duty truck market. But more importantly, the Tesla Semis that will come off this new production line will be somewhat different from what we've seen so far. Musk has been frank that the Semis already on the road, even those delivered to customers, are basically early prototypes. They're strategic test units Tesla has been using to gather real-world data and feedback. For that reason, the Semi's design has remained largely unchanged since its debut in 2017. Now it's time for a revolution. The Tesla Semi needs a comprehensive upgrade, not just to look more modern and futuristic, but most crucially, to reach its boldest goal: full autonomy. You heard that right. A Class 8 truck that can operate without a driver while still hauling cargo on public roads. The company revealed a refreshed design through a few limited images at the event. From what we can see, the headlights have been redesigned to match the new Model Y, Cybercab, and Cybertruck. The new light bar stretches across the front of the cabin, giving it a more modern, aerodynamic, and sleek appearance. Looking more closely, Tesla has also equipped the Semi with a new front bumper, while the roofline is now smoother and more rounded. Honestly, we really liked the headlights on the original Tesla Semi prototype. They looked like the truck's eyes, and the illumination was quite impressive, especially in nighttime footage of the Semi in operation. However, the new headlight design gives us the feeling that the updated Semi will look more futuristic and even cooler. Currently, the Tesla Semi achieves a drag coefficient of 0.36, a remarkably low number for a Class 8 truck. Tesla's decision to design the Semi inspired by Japan's #1 high-speed train helped it reach this figure. This is the key factor that allows the truck to accelerate from 0 to 60 miles per hour in just 20 seconds. With the upgraded version, this coefficient could be optimized even further. A drag coefficient of 0.34 is entirely feasible. This is no small matter. In fact, improving the drag coefficient by just 0.02 can reduce energy consumption by 5 to 7%, which translates to dozens of additional miles of range per charge. In contrast, Conventional diesel trucks typically have a drag coefficient ranging from 0.65 to 0.70, making them less efficient, more fuel-hungry, and louder due to wind noise. Thanks to its aerodynamic drag being roughly half the traditional standard, the Tesla Semi almost glides down the highway. What do you think of the Semi's new light bar design? In your opinion, which type of headlights would be more suitable? In the new upgraded version, another noticeable change is that the Tesla Semi's windshield has been shortened and set back less toward the rear of the cabin. At first glance, many might assume this is simply a cost-cutting measure by Tesla. However, in reality, it represents a significant step forward in both aerodynamics and safety. In the first generation, the Tesla Semi used an extremely large windshield, giving the driver an almost panoramic view. But if you look closely, the rear portion of that glass was almost unnecessary. At the same time, that rear section created considerable wind resistance at high speeds and added to production costs. So, Tesla likely redesigned the windshield, making it shorter while maintaining its full width. This design allows air to flow more smoothly over the surface, significantly reducing turbulent areas around the A-pillars. As a result, the overall drag coefficient is noticeably lowered. On top of that, the amount of direct sunlight entering the cabin is reduced, allowing the air conditioning system to operate more efficiently and easing the load on the battery pack. Okay, currently the Tesla Semi is using LFP batteries, but the new version has been confirmed to switch to 4680 cells. The advantages and drawbacks of using this type of battery in the Semi have already been made clear. As we all know, the 4680 is the best battery Tesla produces to date. It offers an impressive energy density of up to 300 watt-hours per kilogram, while also significantly reducing production costs thanks to its breakthrough structural design. But why do we say there are concerns about using 4680 cells in the Semi? It's quite simple. Unlike passenger cars, the Semi is a heavy-duty transport system that runs continuously, carries extremely high loads, and operates under much harsher conditions. Here, the biggest advantage of the 4680 lies in long-term performance. When you're hauling tens of thousands of pounds at high speeds, internal resistance and heat dissipation become critical factors. The tabless design of the 4680 helps reduce voltage drop, maintain more stable power output, and optimize energy efficiency over long journeys. This not only helps the Semi save electricity, but also maintain a steady speed on the highway, one of the key requirements in the transportation industry. But the downsides are also quite clear. The 4680 offers high energy density, but that comes with extremely stringent thermal management requirements. A Semi running at a total weight of 80,000 pounds is not like a Model Y driving around the city. The heat generated from continuous high current discharge puts significant strain on the cooling system. Tesla has had to redesign the entire pack, from the cell-to-chassis structure to the new generation liquid cooling system. In other words, if Tesla's optimization isn't precise enough, the battery could overheat, leading to reduced power when climbing hills or driving long distances at high speeds. This is the biggest risk of the 4680 in a heavy-duty environment. Another point that often goes unnoticed. While the 4680 helps reduce the overall weight of the pack, it also increases the stiffness of the vehicle frame when integrated directly into the chassis. This improves cornering ability, stability in crosswinds, and long-term structural durability. However, repairing or replacing the pack becomes more complicated and expensive since the battery and chassis essentially become a single, unified unit. LFP batteries have proven their ability to handle continuous charge and discharge very well in industrial environments. The 4680, however, has not. So Tesla will need at least 1 to 2 years of real-world operation to demonstrate that the 4680 can withstand hundreds of thousands of kilometers of heavy-duty travel, high-intensity megawatt charging system use, and still maintain the expected stability. Tesla has also announced that the upgraded Semi now supports higher payloads, although they have not disclosed the exact figure. This opens up the possibility for fleets to transport more cargo per trip. The maximum allowable weight, including both the truck and its cargo, is currently 82,000 pounds. The ability to carry heavier loads also means the Semi's own weight can be further optimized. Specifically, the long-range Semi is currently confirmed to weigh around 23,000 pounds. With the new design and the 4680 battery pack, Tesla could potentially reduce the Semi's weight below 23,000 pounds. This design not only improves operational efficiency, but also increases driving range and optimizes the vehicle's cargo capacity. Another key improvement in the Tesla Semi Gen 2 directly relates to charging capability. The truck now supports a maximum power of up to 1.2 megawatts, far beyond the current megacharger capacity. When paired with compatible charging infrastructure, this allows fleets to significantly reduce charging downtime, thereby improving operational efficiency. Another very noticeable change in the new design is located just above the front wheel well. The black triangular shape protruding from the body clearly indicates a new camera mount. This quietly underscores the greatest potential of the Tesla Semi, a Class 8 truck capable of full self-driving without a human driver. While there are currently hundreds of electric trucks on the market across the US and Europe, none can fully drive themselves with a fully loaded trailer behind them. It seems Elon Musk is betting on a much bigger gamble for the Semi, a fully autonomous, zero-emission tractor that doesn't compromise driver longevity. Over the past year, some footage has shown the Tesla Semi testing FSD capabilities on highways. No results have been officially reported, but that doesn't mean Tesla has given up. The biggest advantage of pairing the Semi with FSD is stability and operational optimization. Humans get tired, robots don't. While traditional trucks must stop regularly due to regulations, a self-driving Semi could operate almost 24/7, stopping only for fast charging via the megawatt charger. This creates an entirely new transport cycle, with delivery speeds potentially many times faster than today and significantly lower shipping costs. Most importantly, it can assist human drivers on long-haul routes without compromising their health. However, deploying FSD on the Semi will certainly not be easy, both technically and legally. Simply put, rolling out FSD on a sedan or SUV like the Model Y already took several years of testing, and even today it still operates under supervised conditions. So, to achieve stable FSD operation on a Class 8 truck weighing 20,000 pounds and towing tens of thousands of pounds of cargo, Tesla must overcome a host of technical challenges that passenger cars never face. FSD on a semi-truck must anticipate farther ahead, make decisions earlier, and with much greater precision than a car. This is why FSD on the Semi could be Tesla's toughest test ever. When a passenger car makes a self-driving error, the risk is already significant. But when a Semi with a total weight of 80,000 pounds makes a mistake, it becomes a matter of national concern. That's why Tesla must demonstrate that FSD is not only good enough, but industrially reliable, capable of handling complex highway situations and emergency collision avoidance while carrying heavy loads. Dan Priestley, leading engineering and program development of the Tesla Semi, he wrote on X. The new front end, besides having a new look, is packed with improvements. More aerodynamic, simpler to build, easier to repair, leverages more components from car lineup for better scale/lower cost. More technical details on these to come. It's clear that Tesla is focusing on optimizing production costs for the second-generation Semi. The redesigned front end not only helps reduce aerodynamic drag, but also simplifies manufacturing and maintenance. Many components are now shared with other Tesla models, such as the Cybertruck and Model X, providing economies of scale, a key factor in reducing production costs while maintaining profit margins. As a result, although Tesla has not yet announced official pricing, experts predict that the Semi Gen 2 could fall in the range of $150,000 to $190,000, depending on configuration and driving range. This version is expected to be far more refined than the current prototype, from operational efficiency to cost optimization. For years, one of the most notable debates in the EV industry has been Bill Gates' stance on battery-powered heavy-duty trucks. Gates has publicly stated that electric trucks are not a practical solution. He argued that batteries would be too heavy, range too short, and operating costs too high for a Class 8 tractor to compete with traditional diesel. In Gates' view, a perspective shaped by decades in the software world, the energy landscape is fundamentally limited by battery energy density, and a fully electric Class 8 truck simply isn't feasible. But at that very moment, Elon Musk took the opposite stance, claiming that Bill Gates has no clue about electric vehicles. The launch of the Tesla Semi became, in a sense, a direct rebuttal to Gates' viewpoint. When the first Semi prototype appeared in 2017, many experts were skeptical. They saw it as yet another exaggerated promise from Elon Musk, either stock-pumping hype or a prototype that would never reach production. But once PepsiCo received the first Semis and long-haul routes began operating in the real world, the entire industry had to rethink what they previously believed was impossible. The turning point was the 500-mile full-load trip completed on a single charge. No reduced speeds, no lightened cargo, no special conditions. The Tesla Semi operated exactly like a Class 8 truck should: high speeds, maximum payload, and consistent energy consumption. This achievement directly challenged Gates's argument. Gates believed that batteries would need to be huge and twice as heavy to support long-range hauling, while Tesla proved that the solution isn't about oversized batteries. It's about optimizing the entire system from end to end. You know, it's no coincidence that governments in many countries support electric trucks. With electric trucks, the energy cost per mile is about 30% lower than diesel, depending on electricity prices and route conditions. Electric motors don't require engine oil, oil filter, changes, exhaust systems, turbos, complex transmissions, or the hundreds of moving parts found in a diesel engine. This dramatically reduces maintenance costs and minimizes downtime, making logistics operations more efficient and more predictable. On top of that, regenerative braking recovers kinetic energy and turns it into electricity, reducing wear on mechanical brakes and extending brake pad life by many times, a major cost factor for traditional fleets. Beyond cost savings, the energy efficiency of electric trucks is fundamentally superior. Electric motors operate at 65 to 85% efficiency, while diesel engines typically sit around 45 to 50%. This means every kilowatt-hour of electricity is used more effectively, producing stronger and more consistent torque. Heavy load acceleration, steady hill climbing, and maintaining high speeds are all areas where electric trucks excel. The low center of gravity, thanks to the battery pack mounted under the floor, also improves stability, reducing sway or instability that diesel trucks often experience in strong crosswinds. Finally, electric trucks offer clear environmental benefits. No emissions, and they help businesses meet increasingly strict environmental standards. In an industry that consumes an enormous amount of fuel, the arrival of electric trucks is not just a technological advancement, it represents a strategic transformation for the entire logistics sector. In theory, this means cleaner air, safer roads, and a more abundant supply of goods delivered at lower cost. If it becomes reality, it would be a massive leap forward. Production of the Tesla Semi at the new factory is reportedly on schedule to begin large-scale output in 2026, and it would be hard to argue that the Tesla Semi won't take over in the coming years. So, do you think electric Class 8 trucks like the Tesla Semi can really replace diesel in long-haul trucking? What impresses you the most about the Tesla Semi Gen 2? Drop a comment below. Sodium-ion batteries arrived late to the game, but they've quickly become far more powerful. Tesla has made moves toward adopting its most advanced sodium-ion battery technology yet, the Tesla Sodium-ion Battery 4.0. Elon Musk has said before that Tesla has studied many potential battery chemistries, but only a few were truly suitable for Tesla's needs, and sodium-ion is one of the rare exceptions. Early generations of sodium-ion batteries had energy densities far too low for electric vehicles, reaching only about 100 watt-hours per kilogram compared to the minimum requirement of 150 watt-hours per kilogram. But Elon Musk and Tesla didn't give up. They improved the materials and successfully developed a sodium-ion battery with an energy density almost equal to today's LFP cells, while cutting the charging time down to just 3 minutes. Oh my God, this is the first time a sodium-ion pack has ever achieved this, and it's something Elon can't really ignore. Right now, batteries are no longer the major bottleneck for Tesla, especially with the 4680 production lines ramping up at incredible speed. Of course, those packs are reserved for higher-end models like the Tesla Semi and Cybertruck. But with the upcoming $26,000 affordable Tesla launching next year, the company needs a stable, far cheaper battery than traditional LFP cells if it hopes to scale production. So, will the new sodium-ion battery 4.0 be the one Tesla uses? What makes this battery special enough to replace lithium, and why is it on track to become the cheapest EV battery in the world? It's not solid-state batteries or any other high-energy density chemistry that automakers are turning to as a backup plan. It's sodium-ion. With lithium prices rising, sodium-ion batteries are becoming the preferred alternative, especially for lowering production costs in affordable cars. We've seen many battery technologies emerge alongside lithium over the past few years. Among them, sodium-ion has shown the most promise, improving its energy density by 40% in just 2 years, a pace faster than any other battery technology in the world. And most importantly, sodium has one advantage no other chemistry can match: abundance. It's everywhere in nature, making it extremely cheap to source. Sodium-ion batteries are estimated to cost around $40 to $80 per kilowatt-hour, compared to the roughly $120 per kilowatt-hour of lithium-ion packs. In terms of availability alone, sodium is 500 to 1,000 times more abundant than lithium on Earth. On top of that, the extraction process is far less harmful to the environment and land compared to lithium mining. Although Elon Musk has stated that Tesla's new battery tech has eliminated lithium entirely, he also noted that the overall structure still closely resembles the lithium batteries Tesla used before. Simply put, the Tesla sodium-ion battery 4.0 still has a cathode, anode, separator, and liquid electrolyte. But instead of using lithium as the charge carrier, Tesla uses sodium. Additionally, both the cathode and anode can use aluminum, whereas lithium-ion batteries require copper for the anode, a significantly more expensive metal. Not stopping there, Elon Musk stated that the production cost of the new battery is even many times lower than that of the current 4680 cells. Instead of using expensive and scarce materials like nickel, cobalt, lithium, and copper, Tesla's fourth-generation sodium-ion batteries use a sodium-based cathode and rely on abundant, eco-friendly materials such as iron, aluminum, or manganese. In terms of test performance, Tesla's sodium-ion battery reaches 190 watt-hours per kilogram, higher than CATL's sodium-ion battery at 175 watt-hours per kilogram. So far, almost no sodium-ion battery has achieved such specs. CATL has said they will soon reach an energy density of 200 watt-hours per kilogram in the next generation of their sodium-ion batteries, but that still hasn't happened. Honestly, 190 watt-hours per kilogram is not a very high energy density. It's even significantly lower than Tesla's 4680 cells. But when compared to LFP batteries, which are widely used by many EV makers, it's clear that Tesla's sodium-ion batteries are not inferior. In fact, they're slightly better, even without taking production cost into account. With a 62 kilowatt-hour pack, Tesla's sodium-ion battery allows for a 300-mile range. Achieving a 300-mile range with a sodium-ion battery has never been an easy task. No sodium-ion battery has managed to do that before. According to Elon Musk, recent advances in material technology have significantly improved the performance of sodium-ion batteries, overcoming their inherent weakness in energy density. In terms of charging speed, sodium-ion batteries are very promising because they've demonstrated the ability to charge and discharge more than 20 times faster than lithium-ion batteries. With just a 3-minute charge, Tesla's sodium battery is said to deliver an additional 110 miles. Oh my God, this significantly compensates for the battery's not-so-impressive energy density. For any battery technology, the key factor that determines fast or slow charging is always the movement of ions between the electrodes during charging and discharging. In Tesla's fourth-generation sodium battery, sodium ions travel between the cathode and anode through the electrolyte. One reason this battery can charge and discharge so quickly is the favorable ionic conductivity of sodium ions in the electrolyte. Sodium ions carry a single positive charge, similar to lithium, but their larger ionic radius allows them to move relatively easily through certain electrolytes, especially those optimized for sodium-ion cells. In liquid electrolytes, Na+ can diffuse rapidly, enabling faster ion transport during both charging and discharging. This level of speed means it could potentially fully charge a Tesla Model Y in just 9 minutes. My goodness, that's practically comparable to filling up a gas-powered car. With sodium-ion batteries, you may get a vehicle with a shorter driving range, but you won't have to wait long before you can start your next trip. This balances out the experience compared to owning a long-range EV that requires nearly an hour to recharge. In Tesla's most recent efforts, the 4.0 sodium-ion battery has been shown to retain 80% of its capacity after 7,000 to 8,000 cycles. And we've also learned that sodium's durability could allow the battery to reach up to 80,000 cycles. But that's not even the most interesting part. Tesla's sodium-ion battery not only has a major cost advantage, but can also be considered one of the safest battery types for electric vehicles. Tesla conducted a series of extreme durability tests, from drilling directly into individual cells to cutting them in half, yet no signs of overheating appeared. This success largely comes from the sodium-based chemistry, which provides remarkable stability for this new battery type. According to Elon Musk, this battery line can operate across an extremely wide temperature range, from -40 degrees Celsius to over 70 degrees Celsius, essentially redefining thermal tolerance standards for batteries. At -40 degrees Celsius, Tesla sodium-ion battery still retains up to 90% of its usable capacity. Even when the battery is nearly empty, its performance barely drops in freezing environments. Compared to traditional lithium batteries, Tesla's sodium-ion batteries exhibit superior resistance to overheating, significantly reducing the risk of fire or explosion. Studies show that sodium's stable chemical structure makes the battery less prone to ignition and harder to explode in the event of a short circuit, increasing safety during technical malfunctions. In addition, sodium is a non-toxic material, which minimizes health risks if the battery breaks or becomes damaged. As a result, concerns about EV fires and thick smoke from lithium batteries are eased considerably. Another major advantage of sodium-ion batteries, and something we value highly, is their ability to maintain stable performance in cold environments. Many battery samples have demonstrated the ability to charge from 5% to 80% in just 15 minutes, even at minus 10 degrees Celsius. This makes sodium-ion batteries an ideal choice for regions with harsh winters, where severe performance drops in cold weather remain a major barrier that causes many users to hesitate before switching to electric vehicles. Okay, Elon Musk rarely talks in detail about battery prices, because even though the 4680 cells have been on the market for several years, their cost is still somewhat of a mystery. While Tesla hasn't disclosed the exact cost of each new battery cell, based on the average market price, if sodium-ion batteries are produced at scale, they could be 30% to 60% cheaper than LFP batteries, thanks largely to the abundant supply of sodium and the lower extraction and refining costs. As we mentioned earlier, sodium-ion batteries can also use aluminum as the positive current collector instead of copper, which is used in lithium-ion batteries, further reducing costs and supply chain risks. Replacing all the lithium in lithium-ion batteries with sodium can cut costs by as much as 30%. And what does that mean? A 30% reduction is a massive advantage. In many cases, just a few percentage points in price difference can determine the survival of an entire industry. If Tesla's sodium-ion battery 4.0 costs around $80 per kilowatt-hour compared to $120 per kilowatt-hour for LFP batteries, that would truly be a game-changer. Have you ever wondered why the industry even needs to turn to sodium-ion batteries when lithium-ion batteries have long been considered the gold standard? The answer is actually quite simple. Lithium-ion batteries can't fully solve the current challenges of electric vehicles, especially as automakers race to produce more affordable EV models. One of the key driving forces behind the rise of sodium-ion technology is that sodium is far more abundant and much cheaper to mine than lithium. This is becoming increasingly urgent as global lithium demand continues to rise and is projected to face severe shortages by 2026, directly impacting lithium-ion battery production. Although lithium naturally exists in various types of rock and even in brine, its reserves in the Earth's crust are far from limitless. Lithium extraction also consumes significant energy and resources. As demand for this valuable material keeps increasing while natural supply remains limited, lithium prices have surged dramatically, earning it the nickname "white gold" of the battery and electric vehicle era. For the electric vehicle industry in particular, sodium-ion batteries offer a substantial advantage, especially for Tesla and its ambition to introduce a $26,000 EV, a goal Elon Musk has long pushed for. Thanks to their low cost and independence from increasingly scarce lithium, adding a new battery chemistry like sodium-ion to the ecosystem brings long-term benefits. This becomes even more important when forecasts suggest lithium demand could increase by as much as 500 times in the future, making battery technology diversification not just a choice, but a survival strategy. As a key partner of Tesla, CATL is expected to soon introduce its second-generation sodium-ion battery. CATL has announced a target of reaching 200 watt-hours per kilogram for the next-generation version, currently in development, compared to the current generation's 175 watt-hours per kilogram. Furthermore, as we discussed earlier regarding sodium-ion technology, a former Tesla engineer has founded his own company dedicated to developing this type of battery. He is confident that his sodium-ion batteries will deliver a driving range of up to 300 miles. One of the most ambitious claims we've heard so far about sodium-ion batteries. So can Naxtra sodium batteries replace lithium batteries? In our opinion, the answer is no. Sodium batteries will not replace lithium batteries in the short term. Within the industry, it is widely believed that sodium-ion and lithium-ion batteries are complementary, not replacements for each other. Due to the lower energy density of sodium-ion batteries, they are more suitable for use in medium to low-speed electric vehicles and in large-scale energy storage systems. As industry investment increases, the technology matures, and the supply chain improves, Cost-effective sodium-ion batteries are expected to become an important supplement to lithium-ion batteries, particularly in the field of stationary energy storage. They have a strong potential for development. Battery demand generally revolves around higher capacity, faster charging speeds, improved safety, and lower cost. From this perspective, aside from not yet being able to meet high-capacity needs, sodium-ion batteries have advantages in all other aspects. At this stage, sodium-ion battery products will primarily be used in applications requiring less than 150 watt-hours per kilogram, which could help alleviate the limited development of energy storage systems due to lithium resource shortages. There are no obvious bottlenecks for large-scale mass production of sodium-ion batteries, and they will rapidly gain market share with their unique characteristics in specific markets. Sodium-ion batteries are positioned as the most cost-effective and highly safe energy storage batteries. Once mass production is achieved, their performance is expected to reach that of lithium-ion batteries, but at the price of lead-acid batteries. The development of sodium-ion batteries is a process of self-innovation. Eventually, sodium-ion batteries will directly compete with lithium batteries for market share. Although CATL has outlined a clear timeline, the industrialization of sodium-ion batteries still needs to overcome challenges related to technical performance, supply chain development, large-scale manufacturing, and cost reduction. The inherent limitation of low energy density in sodium-ion batteries is widely acknowledged, and efforts to optimize this have never stopped. Increasing the energy density from 160 watt-hours per kilogram to 200 watt-hours per kilogram has become the key R&D goal for CATL's second-generation sodium-ion batteries. Naturally, improving energy density presents a time and effort-intensive challenge. Beyond energy density, current sodium-ion batteries can reach a cycle life of up to 5,000 cycles, though this is still significantly lower than that of commercial lithium iron phosphate batteries, which can last 8,000 to 10,000 cycles. To become the backbone of energy storage applications, sodium-ion batteries still need to go through further technical validation and improvement. In addition to Naxtra, CATL has also introduced the second generation of its Shengsing battery, which is expected to be installed in 67 vehicles this year from Chinese brands like Zeekr, NIO, and Avatar. This fast-charging battery can support a range of 800 kilometers and deliver 520 kilometers of range with just 5 minutes of charging, outperforming rival BYD from China. Its charging speed is truly impressive. CATL shared examples of vehicles charging at around 1,000 kilowatts, maintaining over 500 kilowatts even when the battery is more than 50% charged. CATL is also betting on the growth of battery swap systems, such as with its partner NIO, to help roll out its new battery technologies more widely. In summary, Naxtra sodium-ion batteries are emerging as a promising alternative to lithium-ion batteries in electric vehicles and energy storage applications. Over 18.32 million vehicles equipped with CATL batteries are currently in operation across more than 66 countries, demonstrating the reliability and effectiveness of the technology. Thanks to their high safety and the abundant availability of sodium, sodium-ion batteries reduce dependence on lithium resources, which is a key factor in solidifying the foundation of next-generation energy technologies. This shift not only brings sustainability benefits, but also drives the transition from resource dependence to energy independence, a major leap toward achieving clean and efficient energy goals. Technical issues like slower charging compared to refueling have already seen significant improvements, making EV charging more convenient. However, infrastructure development and technology costs still remain critical factors in making sodium-ion technology widely accessible to consumers. Forecasts suggest sodium-ion batteries could become mainstream within 2 to 3 years, even though lithium-ion remains the dominant choice for EVs at present. The Tesla Model 2, the $26,000 electric car Elon Musk has mentioned, remains one of Tesla's biggest mysteries. Although it's expected to be an affordable mass-market model, one of the most critical factors in achieving that price point is battery cost. While Tesla has already adopted LFP batteries for the more budget-friendly versions of the Model 3 and Model Y, there's still a significant gap to bridge before reaching the $26,000 target Musk set for the Model 2. In other words, LFP batteries are still not cheap enough to make the Model 2 viable at that price. As Tesla works to make EVs more accessible and reduce production costs, sodium-ion batteries are emerging as a compelling option thanks to 3 core advantages. low cost, good charging speeds, and high safety. Although it's unrealistic to expect them to outperform lithium-ion batteries, sodium-ion technology could still help budget-conscious customers experience owning a Tesla EV. And if the energy density challenge is solved in the near future, mass production of sodium-ion batteries at the Nevada factory may only be a matter of time. When weighing the pros and cons of sodium-ion and lithium-ion batteries, it's clear that each technology has its own strengths. Choosing the right battery depends on the specific application, cost considerations, and environmental impact. In this race, sodium-ion batteries stand out as a promising alternative due to their affordability, environmental friendliness, and high safety. However, lithium-ion batteries continue to dominate thanks to their superior energy density, well-established technology ecosystem, and continuous pace of innovation. In summary, the competition between these two battery technologies reflects the energy sector's dynamic shift toward more sustainable and efficient storage solutions. As technology continues to evolve, the coexistence of sodium-ion and lithium-ion batteries will provide more flexible approaches to meet the world's increasingly diverse energy needs. Okay, so if Tesla released a $26,000 EV with sodium-ion battery, would you be interested?
We need to make sure that it works. This is some crazy, crazy technology. I think it has a shot at being the most memorable product unveil ever. It has a shot.
We think most of us don't really want to live in tiny houses. Yeah, they're cramped and can feel suffocating. However, when we looked into the cost of building a house in the US, the search results practically made us faint. Okay, the average cost to build a house is $350,000 to $800,000, not including land or site prep. And the average construction cost is $180 to $280 per square foot for a basic home with standard finishes. Oh my God, that's why so many Americans have turned to Tesla and placed pre-orders for the Tesla tiny house, 300 square feet, priced at only $8,000.
A cost of maybe, at really high scale, of about $10,000. It's smaller, it'll be less expensive than a car.
This is the latest product model announced by Elon Musk, and he believes it will be the one that transforms the entire company. Simply put, it will shatter every assumption we've ever had about affordable housing in the United States. This is the first mass-market housing model that removes the three biggest barriers preventing millions of Americans from owning a home: the cost of land, the complexity of building permits, and property taxes. Elon Musk said Tesla's legal team spent 10 months working with federal agencies to classify this housing unit as a mobile structure, allowing it to completely bypass traditional real estate regulations. This means no mortgage paperwork, no credit checks to buy land, and, most importantly, no annual property taxes. So how is the Tesla tiny house built, and what makes millions of people eagerly waiting for it? What's inside a 300 square foot space?
You can set it up any way you want. You can paint it whatever you want, and it'll be set up and paid for really quick.
Yeah, no one really thought Elon Musk would get into real estate when he's already busy with cars, robots, and rockets. But we were wrong. Elon Musk will do anything he wants, and he's willing to pour billions of dollars into a project if it has the potential to generate profit for the company and help people. Of course, there's one condition for any new product: it has to be sustainable, and Tesla must be able to produce it without having to start completely from scratch. Coincidentally, the idea of producing modules, wall panels, and certain components for a house already existed at Tesla. More accurately, building a mobile home is surprisingly similar to how they manufacture cars. Elon Musk said Tesla has directly applied experience from its gigafactories to home construction, mass-producing units on automated assembly lines instead of building each house on-site. This innovation alone cuts labor costs by 40% compared to traditional methods. When you can produce thousands of homes in the time it takes to build just one conventional house, the entire economic model is completely flipped. Hold on, you might be thinking that producing homes this fast must mean the quality can't possibly be good. Yeah, we thought the same thing, but the reality is completely different. The real breakthrough lies in the materials Tesla invented. There are no flimsy drywall partitions or fragile components. Tesla tiny houses are built using advanced technology and ultra-durable materials, including steel, concrete, insulation foam, and multilayer panels. They developed a compressed fiber composite material that's recyclable, 65% cheaper than traditional wood and 40% lighter than steel. This material is based on Tesla's solar roof tile technology, but adapted for walls and insulation layers. Tesla's material technology becomes even more impressive with the use of magnesium oxide in the wall structure. This eco-friendly compound is fire-resistant, mold-resistant, and offers a lifespan of up to 26 years while reducing costs by 25% compared to traditional drywall and insulation systems. Every component is engineered for maximum durability at minimal cost. However, Tesla faced a major challenge: how to build a tiny house inside a factory and then fold it up after production. If it couldn't be collapsed, it would take up too much space and severely limit factory scale. So, Elon Musk admitted that Tesla partnered with Boxable for this project because of their experience in building foldable tiny homes. The collaboration between Tesla and Boxable, a Las Vegas-based startup known for its flat-packed foldable homes, significantly reduced costs, thanks to their collapsible modular design. These homes can fold flat for transport, allowing a single truck to carry an entire house for just a few $100s. Elon Musk explained that the entire structure of the home is manufactured directly inside Tesla's factories, using a few automated robotic processes that have been adapted for a dedicated housing production area. Here, the walls, kitchen, and bathroom modules, energy storage units, solar roofing panels, and smart control systems are all pre-built. Thanks to robotics, Tesla's automated assembly line cuts labor costs from about $45,000 per traditional home down to just $2,800. With robots handling 90% of the construction process, human labor becomes a minor expense instead of the biggest cost factor. While traditional homes cost around $180 to $280 per square foot to build, Tesla's tiny house costs only about $15 per square foot for a 300 square foot unit. That's an enormous difference, one that could truly change the game for people struggling financially. Tesla produced a pilot batch of 100 tiny houses earlier this year at the Nevada Gigafactory. These test units went through extreme structural simulation tests, including hurricane-level winds, earthquakes, and temperatures ranging from -20 degrees Fahrenheit to 120 degrees Fahrenheit. You might think these houses couldn't withstand hurricanes, floods, or heavy snowfall, extreme weather conditions that can devastate buildings. Of course, even traditional homes often struggle to survive natural disasters. But amazing, the results showed no structural damage whatsoever.
How solid it feels and how quiet it seems inside. It just seems like it's got some real substance to it.
For just under $8,000, you can own a 300 square foot living space. It might sound small, but don't be fooled. This efficient design is perfect for 2 to 3 people, offering just enough room, though it may feel a little tight compared to a full-sized home. It features 4 separate rooms and boasts a ceiling height of 9 feet 8 inches, giving it a surprisingly spacious feel. But here's the kicker. The Tesla tiny house isn't just small and compact, it's expandable. Thanks to its smart design, you can easily connect and stack multiple units together to create a 2 or even 3-story home, capable of comfortably housing up to 5 people. If you find that the original 300 square foot layout isn't quite enough, you can add another module and expand your space, either horizontally or vertically. Start small and grow as needed. Sure, additional units come at a cost and take longer to install, but the flexibility to adjust your living space is remarkable. Weighing in at just 6,200 pounds, the Tesla tiny house maximizes every inch of its compact space. At first glance, the idea of living in 300 square feet might make you think, that's way too cramped. How could anyone possibly live in that? We get it, but once you see how it's designed, you'll be amazed at how well the space is used. It doesn't just feel cramped, it feels smart. Despite the small footprint, you get all the essentials of a regular home. A separate bedroom, living room, bathroom, and kitchen. Yes, 4 separate rooms in a tiny house. And here's the surprise. Those 9 feet 8 inches ceilings make the whole space feel more open and airy than you'd ever expect. Now the question on everyone's mind, what's actually inside the Tesla tiny house? Let's take a look.
The bigger rooms, I think they're going to feel it's a very spacious and livable property.
Okay, though we haven't had the chance to step inside the Tesla tiny house yet, the reactions of customers in the video speak volumes about the space's surprising interior. With its clever design, Tesla has managed to incorporate all the essentials, from the living room and bathroom to the kitchen. While the 300 square foot layout may sound tight, everything is arranged efficiently, maximizing every inch. You won't find extra space to spare, but you will find smart use of every corner. Yeah, every inch of the space feels purposeful, warm, balanced, and sleek, in that unmistakable Tesla style. The minimalist design feels rich and not at all empty, which is where the magic happens. At the center of it all, there's a multifunctional space that blends the living room and bedroom. You see a simple neutral-toned sofa, subtly framed against the wall. But Tesla's genius comes into play when, with one smooth motion, the sofa transforms into a cozy bed. The hidden bedding and pillows ensure that your daytime relaxation spot becomes the perfect spot to rest at night. Oh my God, we really want one now. And yes, you can still mount a 55-inch TV on the wall if you want, no compromises there. Shelves are neatly tucked in beside it for books, your photos, and personal touches. The compact space might seem limiting, but it never feels cramped. You can entertain friends, take a coffee, or unwind without feeling like you're bumping elbows. It's the brilliance of Tesla's design, small, yet spacious. Now let's talk about light. We hate houses or rooms that lack light, especially natural light. But with Tiny House, Tesla nailed the lighting design. Massive windows flood the space with natural light, making it feel open and airy. The clever window placement creates a seamless connection with the outside world, and the double-pane insulated glass keeps the temperature just right. When night falls, soft LED lighting fills the space, creating a warm ambiance that perfectly complements the solar-powered, energy-efficient design. Moving beyond the living space, you'll discover a bathroom that redefines the concept of small. It's compact, yes, but the design feels anything but cramped. With frosted tempered glass doors, letting in soft daylight, you're welcomed into a sleek, modern bathroom. It includes a rainfall shower, a floating sink with a mirrored cabinet, and a minimalist toilet. Everything made from premium, easy-to-clean materials. Now, on to the kitchen. Sure, it's small, but don't let that fool you. Tesla's design is ridiculously smart, fitting everything you need into a tiny footprint. The kitchen comes equipped with an induction cooktop, built-in oven, compact fridge, and even a mini dishwasher. Yeah, it's like Tesla looked at a shoebox and said, "Let's fit a full kitchen in here." And that's exactly what they did. Above the counter, the cabinets reach up the wall, providing more storage than you'd expect in a tiny home. Plus, the counter hides a fold-down dining table for two. It's the kind of efficiency that makes small living feel incredibly big. Tesla didn't forget about the air either. The built-in ventilation system ensures the air stays fresh and crisp, removing cooking odors and keeping everything smelling clean. The Tesla tiny house has it all: a full kitchen, cozy bedroom, bathroom, and living space. But let's be real, it's not meant to replace a full-sized home. At 300 square feet, it's ideal for two people, maybe a couple or anyone living that simple minimalist lifestyle. If you have a larger family, it might start to feel a bit snug, but that's where Tesla's modular design comes in. You can connect additional units to expand the space, adding another 300 or even 600 square feet. Suddenly, your tiny home transforms into a 2- or 3-story setup that can comfortably house up to 5 people. The beauty of the Tesla tiny house is that you can start small and expand as your needs grow. No more paying for unused space or massive mortgages. You build what you need when you need it. And of course, Tesla's sustainable living philosophy extends to energy as well. You can add a solar roof and a Powerwall battery system to make your home completely off-grid, generating its own clean energy. The Tesla app lets you control it all, and with upgrades like a 265-gallon freshwater tank, rainwater collection, and waste recycling, this tiny home is fully self-sustaining and built for the future. Believe it or not, the Tesla tiny house starts at just $7,999. That's right, no property taxes, no permits, and absolutely no construction headaches. When you factor in the usual extra costs of traditional homes, things like land, permits, and fees, you'll find that these hidden expenses often end up being more than the house itself. In many cities, the land can cost several times more than the actual house. Tesla has completely flipped this upside down. With their model, you simply place an order, and the home will be manufactured and installed, no surprise fees. The listed price is the final price. Elon Musk revealed that Tesla even offers a land option for those who don't already own a plot. For the first 2 years, Tesla will provide the land for free. After that, they'll handle the entire process, from production and transport to installation, so that when you receive your home, it's not just a shell. It's a fully functional, move-in ready space. Tesla has completely torn apart the traditional home buying playbook. Now buying a home is as simple and transparent as buying a car. It's bold, disruptive, and could totally change what home ownership even means. So how easy is it to order? Simpler than you think. Just click Order Now. No hidden fees, no fine print, no middlemen. A fully finished, move-in ready home arrives right at your doorstep. And even if you don't have land, Tesla's got you covered. They'll provide the land for free for the first 2 years within one of their designated community zones. From start to finish, everything is handled. When the house arrives, it's not just an empty shell, it's a fully functional smart home, already wired with solar power, app-based controls, and all the essentials you need to start living right away. This strategy goes straight for the jugular of the biggest issue in modern housing, sky-high land prices. By eliminating that barrier, Tesla has made homeownership possible for millions of people who thought it was out of reach. Imagine this. You place your order online, and a few days later, a Tesla Semi pulls up with your house on board. In a matter of hours, it unfolds, connects to utilities, passes inspection, and boom, you're home. No mortgage, no paperwork, no 30-year chains. Does it sound too futuristic? Well, Musk insists it's not. He's already confirmed that the Tesla tiny house can be delivered within just 1 to 2 weeks of ordering. The modular foldable design fits perfectly on a Tesla Semi, or even inside a standard shipping container for overseas delivery. This isn't just a concept, it's a revolution. The dream of owning a sustainable, affordable, beautifully designed home is finally here. And it's no coincidence that this mirrors Musk's own journey. In 2020, he sold off nearly all his multi-million-dollar mansions to live in a simple, foldable, tiny home near his workspace. Call it crazy, call it genius, but it's pure Musk, breaking traditions and rebuilding the future, one compact, self-powered home at a time. Looking ahead, it's clear where this could go. By 2028, Tesla tiny houses could be everywhere. In Africa, they could bring electricity and clean water to remote areas. In Europe and North America, they could cut living costs and carbon emissions. In Asia's crowded cities, they could solve the pressing issues of space and energy. But Elon Musk's ambitions don't stop at expanding the Tesla tiny house on Earth. He has previously stated that when SpaceX successfully sends Starship to Mars, he will build a colony and a city on the planet. With a long-term vision, Musk doesn't just want humans to live on Mars, but aims to create a sustainable environment where humans can live and thrive for the long haul. Homes like the Tesla tiny house could play a crucial role in this plan. With a minimalist yet effective design, they can easily be installed and expanded on Mars, where resources are scarce compared to Earth. These homes use solar power, optimize living space, and can be connected together to form larger modules to meet the needs of a community. Musk believes that in order to truly live on Mars for the long term, humans must develop homes that are not only sustainable, but also easily expandable as needed. This project is not just about housing, it's a key step toward establishing a Martian colony, offering hope for the future of humanity. Okay, how do you feel about the idea of living in a space as small as 300 square feet? Do you think modular homes will be the future of housing? Why or why not? Drop your comment below. Thanks for watching. Don't forget to like, subscribe, and hit the bell so you never miss a new video. See you in the next one.